Hi guys, Mrs. Warner here. It's our last geometry honors lesson ever. I know you're so sad. I'm sad actually because I don't get to see you guys. But here's our last lesson, and that will end your geometry career. I'm so proud of you guys and so excited for you for next year for Algebra 2. So we're going to do some equation writing of circles today. Super fun, lots of algebra. And we're even going to do some completing the square from last year in algebra honors. So hopefully you remember all your good skills from last year. So first we're going to check out this fun little example I have here. It says, if we graph all of the points whose distance from the origin is equal to 5, what shape will be formed? Not too hard to think about since we've been studying circles. It's probably going to be a circle. But if we put our point at the origin, I need my pen. If we put our center at the origin and then we go out 5 units in each direction on the axes, you can see that if we connected those points up, look at my freehanding. Whoa, that got crazy. You can make a circle out of that. That's called something called a locus, which we used to teach in geometry, but we don't anymore. It's sad. So there's an actual equation for a circle. First of all, if you think back to last year in your algebra, you know y equals mx plus b is an equation of a line. The x is to the first power, so it's a linear equation. Then you had this guy last year, y equals ax squared plus bx plus c, and that guy made your parabola. And your parabola, because of the x squared, turned it into a u. Now we have x squared and y squared, and when we have x and y squared, that completes your parabola and it forms yourself a circle. Okay, so our formula looks like this. X minus h squared plus y minus k squared equals r squared. Well, h and k in the equation are going to be the center of your circle, because each circle has a center and it has a radius. And guess what? That's what the r is. The r is the radius. Now it's important to note, in the formula, the h and k are negative, but when they actually are pulled out, they turn positive. So they have opposite signs of what is in the formula. So let's just start out by looking at some of these examples here. It says, write an equation for a circle whose center is at 5, negative 6, and has a radius of 12. Okay, we can do it. So we go x minus what our x value is. This becomes our h, and this becomes our k. So we're going to do minus 5, and it's always squared, plus y, but it's minus negative 6, and minus negative 6 turns that into a plus 6 squared. Remember, the sign is opposite of what it actually is there. And then it equals our radius, which is 12, but I've got to take 12 and square it, so that's 144, and that's your equation of your circle with a center at 5, negative 6, and a radius of 12. Not too hard at all, right? Let's try the next one. Now we've got equation for the circle whose center is negative 5, negative 3, and a radius of radical 6. We could do it. We're in honors. So we have x minus negative 5 turns it into plus 5 squared, plus y minus negative 3 is plus 3 squared. And if I square a square root, it's just the number that's underneath. So the end of it equals 6. Doesn't this formula look like a squared plus b squared equals c squared? Hint, hint. Write an equation for a circle whose center is at 9, 0, and a radius is 7. Okay, so now one of our values is a 0. No worries. X minus 9 squared plus y minus 0 squared. I don't really need to write the y minus 0. You can if you want. I'm just going to write y squared, and its radius is 7, so that means 7 squared is 49. Easy peasy. Let's try work backwards. Let's, given the actual equation, work backwards to get the center and the radius. Now you got to remember, with the center, the signs are switched. So if it's positive 12 and negative 4 in the formula, when it comes out, it's negative 12 and positive 4. And remember, to find what's back here for the radius, you take the square root this time instead of squaring because it's opposite operation. So it's a 9. Okay, the next one, our center is going to be a negative 7. And if there's nothing with the y, remember that was 0. And now our radius back here is the square root of 21. So square root 21. Super easy. Okay, let's check out the next page. Oh, we've got some graphs, and we're going to write the equations based on the graph. We can do it. Let's check out this first one. Holy cow, I can't even read it. I think it's negative 2 fourths is its center. Okay, so if it's negative 2, that's going to be x plus 2 squared. And if it's a positive 4, it's going to be y minus 4 squared. And since I'm a genius honor student, I can see that radius is 2, and 2 squared is 4 for my end of my equation. This guy has a center at 0, negative 3, and it has a radius of 3. Okay, so that's going to really be just x squared plus y plus 3 squared, and then its radius is 3 squared, or 9. Super fun. These are graphing. I don't think we have too much graphing that we have to do, but we'll try one of these. Like my center on this first equation here is negative 1, positive 2, and my radius is, oh, I'm frozen. I was frozen. My radius is 4. So I would, oh boy, this is going to be bad, trying to do this on my Chromie. So we're down negative 1 and over 2. Whoa, what the heck am I doing? I'm back 1 and down 2. That was crazy. And we're going to go over 4. 1, 2, 3, 4, and then up 4. Look at Mrs. Warner. I made this graph and it doesn't even fit. 1, 2, 3, 4. I'm getting tired. It's the end of the year. Okay, so here we go. Whoop. There it is. That's our circle. Okay, so now let's get into some crazier stuff here. Okay, if you look at this next example, we're going to get into some really good algebra. This is going to sort out who knows their algebra and who doesn't. And I already know who does and who doesn't. We've got a circle is given by the equation x squared plus 2x plus 1 plus y squared plus 4y plus 4 equals 121. Write the equation of the circle in center radius form and name the center and the radius. Okay, so I don't know if you remember or not, but this x squared plus 2x plus 1 really factors to x plus 1 times x plus 1. Whenever I see a trinomial, I like to factor it. Another way to write that is x plus 1 squared. All right, let's try the same idea with this guy. Y squared plus 4y plus 4. Oh, that's a piece of cake, Mrs. Warner. That's y plus 2 times y plus 2. Or y plus 2 squared equals 121. Look at what we have now. Just like the problems we started with before. So now my center is at negative 1, negative 2, and my radius is 11 because the square root of 121 is 11. Look at that good algebra. If you're good at factoring, you're going to be great next year. Okay, now look at these next ones. All right, same idea. It just doesn't have the parentheses in there. But you guys know that this is really x plus 2 times x plus 2, or x plus 2 squared. This guy in the back is really y minus 3 times y minus 3, or y minus 3 squared equals 36. Now that it's in the correct standard form of a circle, we can find its center. So its center is now at negative 2, but positive 3. Oh dear, look at that. And our radius is going to be 6, because the square root of 36 is 6. This guy over here is going to be x minus 5 times x minus 5, or x minus 5 squared. And back here I've got y plus 7 times y plus 7, or y plus 7. I'm frozen. Plus 7 squared equals 4. So now my center is at 5, negative 7, because we switch our signs. And our radius is 2. Oh, we're doing so good. I'm so proud of everyone. Okay, now let's try down in here. What happens if you cannot factor from the beginning like we did in the last two examples? So if you look at like this example down here, see how it's not actually having that third term of the quadratic so that we can factor it? Well, we can find that. I don't know if you remember how to complete the square or not, but let's do a little Algebra 1 review in case some of you are rusty on this, or if your teacher decided to just cut it out of the curriculum last year and not teach it to you. I've seen that happen before. Okay, so in order to complete the square, you have to have the constant, they call it, on the right-hand side. So you don't want it set equal to 0 like we normally see in most quadratics. We want this 45 on the other side. Okay, now that it's over there, I like to call what I call the magic box. And in the magic box, you take half of the b term. Now in this case, remember it goes ax squared plus bx plus c. The b in this case is actually the 4. And if I take 4 and divide it in half, it is 2. Okay? Now I take that number, that 2 I just got, and I'm going to square it, and I have 4. What I did was just complete the square of x squared plus 4x. So now that square, or that second number in the box, gets added to both sides of the equation. So the second number from the box gets added to both sides. So I took this guy here. My pen won't let me write. Gets added to both of these. Now I'm going to factor the left side. Okay, well, if I factor it, just like I did before, that's x plus 2 times x plus 2. Or remember, I can write that as x plus 2 squared. And what's 45 plus 4? 49. So this is really equal to x plus 2 squared equals 49. Oh, we're going to use that, people, down here. So basically, this guy is missing its other term in the back, and so is this y. Okay, let's look at just the x's first. X squared plus 4x. And I'm going to take and complete the square with just the x's first. So if I complete the square, I'm going to take the 4, divide it in half and get 2, and then take 2 and square it, and I have 4. Okay, so that means this x squared plus 4x now has plus 4. But remember, if I add it to the left side, it also needs to get added over to this 41 on the right side. Okay, now I've got y squared minus 12y. Let's complete the square for the y's. So I'm going to take the negative 12 and divide it by 2, and I get negative 6. If I square negative 6, I get positive 36. So that means it's now y squared minus 12y plus 36, and I add the 36 to the right-hand side. Well, if I add up the right-hand side, all of that together equals 81. And I don't know if you noticed this trick or not, but up here, see this 2? The 2 was really the same thing in the bubbles here. If I factored these guys, here it's x plus 2, x plus 2, so it's really x plus 2 squared, And sure enough, that 2 was the first thing in my bubbles. What do you think this guy is going to be? The first thing over here is the y minus 6 squared. And sure enough, this guy would factor to be y minus 6 times y minus 6, or y minus 6 squared equals 81. Okay, now I haven't even found the center, but in this case, my center now, I can easily see it from my equation, is negative 2, 6, but my radius is 9. That was super fun. Super fun. Should we do another one? Yeah, we should, Mrs. Warner. Let's do it. Okay. Our x's are not complete. I'm freezing up, people. Oh, I was really frozen for a while there. Our x's are not complete and neither are y's. Okay, so let's just work on our x's first. And I've got x squared minus 20x. So that means negative 20 divided by 2 is negative 10. Negative 10 squared is 100. So it's going to be x squared minus 20x plus 100. And that 100 gets added to the 35 also. Okay, now let's look at our y's. We've got y squared plus 6y. So I'm going to be taking half of 6, which is 3, and 3 squared is 9. So now it's going to be y squared plus 6y plus 9, and I'm going to add 9 over here. Oh, I was frozen. Okay, so see this mess I made here. So that equals, what's 35 plus 100? Plus another 9. 144! It's a perfect square. And then over here, since I'm an honors genius, I know this is really x minus 10 squared, because negative 10 and negative 10 add to negative 20. And when you multiply them, you get a positive 100. And this guy is going to be y plus 3 squared, because 3 and 3 add to 6, and 3 times 3 is 9. And I can also see that from my magic box over on the side here. So now I totally ran out of room here. My center is 10, negative 3, and my radius is 12. That was fun, folks. And that was it. That was our last Geometry Honors lesson of the year. And I'm so sad that I didn't get to see you guys at the end here. But hopefully somebody out there watched my videos, because I spent lots of time making these. And I hope you guys are well. And that was it. Okay. Bye now.